Hello friends, welcome to Susan and John MathTube. In this video, we are going to learn how to find the radius of curvature when equations are given in parametric form. In the last video, we were focusing when the equations were given in Cartesian form, and in this video, it will be for parametric form. Okay, so basically parametric form means every coordinate in the system. For example, if you are looking at this curve, there are infinite number of points here, and every coordinate, if given the name xy, will be expressed in terms of a third variable, namely t or theta, phi, etc. etc. And another thing, as an engineering student, you should be very good with the parametric form of the standard curves like parabola, ellipse, hyperbola, of course the circle because it's a special case of ellipse, and asteroid, hypocycloid, etc. etc. You should be very good with. Anyway, there are two formulae. One, if you're really good in differentiation, then I will strongly suggest you use the same formula we learned for Cartesian. But I am repeating, you should be very good in differentiation for this, because when you differentiate a parametric form 2 times for the second order derivative, there is a special thing to be done while finding the second order derivative. And if you don't want to take that risk, you can use the formula x dash, where dash stands for the derivative, squared plus y dash squared, the whole power 3 by 2, the whole divided by x dash y double dash minus y dash x double dash. Okay, let's try one question. Okay, the question goes like this. Are you ready with pen and paper? Okay, let's start. So, find rho, the radius of curvature at any point on the cycloid given by x is equal to a into theta plus sine theta and y is equal to a into 1 minus cos theta. So what are we trying to find? We are trying to find the radius of curvature, and the curve is a cycloid. Actually that is like what you call tracing the movement of a wheel. For example, you take a wheel, you can imagine, you can do this experiment. You can think about the tire of a car or a truck or a scooter or anything. Just mark one point on the circumference, and now just imagine the tire started moving. So when the tire moves, what happens is a curve like this will be generated, and that curve is called the cycloid. So remember, cycloid is about, or the locus of, the movement of a wheel. Okay, so let's start. If you want, you can use the second formula, but I'm going to use the first formula itself. So, first I'm going to find dx by d theta. So that will be a into 1 plus cos theta, right? Theta is 1, cosine theta is cos theta. Now I will find dy by d theta, and that gives me a into, this will become 0, cos theta differentiated gives minus sine theta. So basically I am going to get a into sine theta. Now I am going to find y1. y1 means dy by dx, and that is given by dy by d theta by dx by d theta, and that will be a sine theta, the whole divided by a into 1 plus cos theta. So I think you are quite okay up to this, and I want you to put our dx by d theta in a box. And if you want, you can call it equation number 1. I think we should apply the half angle formulae. Do you remember half angle formulae? What is sine theta? Isn't it 2 sine theta by 2 cos theta by 2? The whole divided by 2 cos square theta by 2. So 2 will get cancelled. So we get y1 is equal to tan theta by 2. Now look at this. We have dy by dx is equal to tan theta by 2. Now remember, in parametric form, there are 3 variables, x, y and the parameter. Now this clearly tells us the derivative is in terms of theta, not in terms of x. The derivative is in terms of theta, not in terms of x and y. So when we find d square y by dx square, or the second order derivative, or y2, you have to notice that we are differentiating with respect to x. So look at this, we are differentiating with respect to x. That means you are differentiating tan theta by 2 with respect to x. So tan something gives us sec square theta by 2 multiplied by theta by 2, the derivative is 1 by 2 multiplied by d theta by dx, and this was the step that I was warning you earlier. And I always see many students forget this. I'll repeat once more. In parametric form, you should always notice that the derivative will be in terms of the parameter. It won't be in terms of x. So when you differentiate again with respect to x, you should not forget our d theta by dx character. Anyway, it's very easy to find. y2 is equal to 1 by 2 sec square x theta by 2 multiplied by, I'm going to put this as 1 by dx by d theta. Do you remember? I asked you to put something in a box. Our dx by d theta. So now we plug in our dx by d theta. So 1 by 2 sec square theta by 2 multiplied by 1 by the way, I think I'll apply half angle formula directly, no need for any drama. So a into 2 cos square theta by 2. So you'll get a into 2 cos square theta by 2, and you can put it by equation 1. So we end up with y2 is equal to 1 by 4a. 1 by cos is sec theta, so we end up with sec to the power 4 theta by 2. That's it. Now we have the capacity to apply the formula which we used for Cartesian. So what is the radius of curvature at any point? It is 1 plus y1 squared. Where is my y1? So 1 plus tan theta by 2 the whole squared, the whole power 3 by 2, the whole divided by 1 by 4a sec to the power 4 theta by 2. By the way, do you remember what is 1 plus tan square theta by 2? Of course, sec square theta by 2 and whole power 3 by 2. I think you did not forget a power m, the whole power n gives you a to the power m into n. So sec square theta by 2, the whole power 3 by 2 is going to give you sec cube theta by 2 the whole divided by, okay, I'm going to put it as a product, 4a divided by, so we get the answer 4a cos theta by 2. Okay. Now, by the way, in case they ask what is the radius of curvature when theta is equal to 45 degree, they won't ask that, it's already 9. Okay, let's say what is the radius of curvature when theta is equal to 90 degree? Just plug in theta, just plug in theta is equal to 90 degree, so that you get cos 45, that is 1 by root 2. Or maybe they will ask what is the radius of curvature when theta is equal to 0 degree? You plug in 0 degree, you get cos 0 is equal to 1, so the radius of curvature will be 4a. So that's it. Once more I am telling you, if you did not like this method, you can follow method number 2 and you will get the same answer. Okay, now let's go for another question. Please write, for the curve given by x is equal to a cos theta plus theta sin theta, y is equal to a into sin theta minus theta cos theta. So clearly it is parametric form. How do you identify parametric form? Our x and y will be given in terms of a third variable, and usually the third variable will be theta or t. Okay, so they want you to find the radius of curvature of this particular curve, and there is one more part. Show that the radius of curvature is proportional to theta. Show that the radius of curvature is proportional to theta. Okay, let's not worry about this. This will eventually happen. Okay, so I'm still going to stick to my method, the formula which we learned for Cartesian. Okay, so let's start. So we want dx by d theta. Before we start, let me color a little bit so that you don't forget product rule when you do. Seen a few students making mistake with that part. Okay, so dx by d theta is equal to a into, what is the derivative of cos theta minus sin theta, plus we apply product rule here. First function derivative of second plus second function, and derivative of theta is 1. So we get dx by d theta is equal to a into theta into cos theta. And now you know I'm going to call this equation number 1, and I'm going to keep it as a very special person and a very important person. Never, never, never forget, our dy by dx will be in terms of theta. So when you find the second order derivative, you'll have to differentiate theta with respect to x, and eventually you will require equation number 1. Now tell me, what is dy by d theta? A into sin theta differentiated gives us cos theta minus a small bracket. What is the derivative of theta into cos theta? Theta into minus sin theta plus cos theta into 1. So cos theta and this cos theta will get cancelled. We get dy by d theta is equal to a theta sin theta. Okay, now tell me please, what will be dy by dx? That is our y1. Dy by dx is dy by d theta by dx by d theta. So we get, we can okay, I'll write and calculate a theta sin theta by a theta cos theta. That is y1 is equal to tan theta. Let's put it in a box. Okay, now comes the most important part. I'll repeat. When we find the second order derivative with respect to x, the problem why many students, the reason behind the mistake is, in examination students will not use dy by dx notation. We learned the formula 1 plus y1 the whole square, we use the formula 1 plus y1 square the whole power 3 by 2 by y2. So students tend to write y1. And the problem with that notation is we forget we are differentiating with respect to x. Anyway, when you find y2, please be very careful if the given format is parametric form. So that means we are differentiating with respect to x. So that will be sec square theta multiplied by d theta by dx. Never forget this. So what is our y2? Sec square theta into 1 by dx by d theta. And we have our special person dx by d theta named as equation number 1. That is, so we get 1 by a theta cos theta. So the final answer for y2 will be 1 by a theta cos cube theta. What I did is I just took sec square to the denominator. It became cos square and multiplied gives us cos cube. So that's it. So we can apply the formula we learned yesterday. So the radius of curvature is given by 1 plus y1 squared. What is y1? Tan theta. Yeah. So 1 plus tan squared theta the whole power 3 by 2. The whole divided by 1 by a theta cos cube theta. What is 1 plus tan square theta? Sec square theta. Whole power 3 by 2 gives sec cube theta. It's not the first time, we have seen this so many times. Multiplied by the reciprocal. A theta cos cube theta. That means the radius of curvature is a multiple of theta. Do you remember we had one more part in the question? We had to prove that radius is proportional to theta. That's it. Therefore, the radius of curvature is proportional to theta. That is, the radius of curvature varies as theta varies. Okay, now this question is very important because I have seen many students doing it wrong. Okay, now before we start, let me make it very clear. I have to explain a few things. So look at this, y square is equal to 4ax is called a standard parabola. Okay, you learned this in class 12. And this parabola will be symmetric about the x-axis. And the vertex will be the origin. The vertex is given by 0, 0. And this point is a very special point. It is called focus. Focus is given by a, 0. That is, the distance between vertex and the focus is a units. Now, you can draw many focal chords. Focal chord means any chord passing through the focus. You can draw many focal chords, and focal chord, my parabola is not correct. That's why you might feel lack of symmetry. So look at this, these are all called focal chords. Now there is one focal chord which is very special, that is called lattice rectum. Now remember, lattice rectum is a special focal chord. First of all, you have to understand there are infinite number of focal chords, not only 1 or 2 or 3, there are infinite number of focal chords. Any chord passing through the focus will be called a focal chord. So you have to understand one thing, that is any chord through the focus will be called a focal chord. Okay. The second thing I want you to understand is the parametric form of a parabola is a_t square, 2at, and it is nicknamed as t of the parabola. Or if someone mentions t of the parabola, you have to take at square 2at. And if someone says t1 of the parabola, it means the specific point at1 square 2at1. And if someone says t2 of the parabola, at2 square 2at2. Once more, we have the standard parabola y square equal to 4ax. Y square equal to 4ax is symmetric about the x-axis. This is not that symmetric, but if you go for the graphing software, you'll get a perfect picture. The second thing, the parametric form of a standard parabola is at square 2at. Now, this is denoted by t. Another important thing, the focus of the parabola is a, 0. Now, focal chord means any chord passing through the focus. Now, if the focal chord is perpendicular to the axis, and of course, if it passes through the focus, then that is called the lattice rectum. And the endpoints of the lattice rectum are given by a, 2a and a, minus 2a. So once more, let me make it very clear. There are infinite number of focal chords for the standard parabola. The lattice rectum is a very special case. Okay. Now, one more thing that you should know before we start with the next question, because I see so many students working out this problem for the lattice rectum instead of general focal chord. So look at this, the result goes like this. Consider any focal chord. So what do you want to consider? Any focal chord. So any focal chord means it will pass through the focus. Now I am going to take the extremities, the endpoints of the focal chord to be at1 square 2at1 and at2 square 2at2. That is, I am expressing the endpoints in parametric form. Now look at this. Let's say this is one extremity E1 and another extremity E2. So look at this. Slope of, if you want you can write slope also. Slope of SE1 is the same as slope of SE2. And you know that slope means change in y by change in x. You can use the formula y2 minus y1, change in y by change in x. Or if you don't want to use this, you can use it like y1 minus y2 by x1 minus x2. The only thing is the direction of subtraction should be same. Okay, so let's start with the first one. So we get change in y 2at1 minus 0 by at1 square minus a. I'll repeat once more. The direction of subtraction should be same. That's all. Is equal to, here I'll find from E2 to S. So 2at2 by at2 square minus a. Okay, now you can see that 2a is common and a is going to come common. So t1 by a into t1 square minus 1 is equal to t2 by a into t2 squared minus 1. So a is going to get cancelled, cross multiplying. T1 t2 squared minus t1 is equal to t2 t1 squared minus t2. Okay, I just cross multiplied and distributed. I skipped one step. Okay, now what we do is, let's take everything to one side. So T1 T2 squared minus T2 T1 squared plus T2 minus T1 equal to 0. Now what's common here? T1 T2 into T2 minus T1 plus T2 minus T1 equal to 0. Now again we have something common. You can see that. So we get T2 minus T1 common, and the remaining part T1 T2 plus 1 is equal to 0. This cannot be 0 because if T1 and T2, then it means we are talking about the same point. Remember, T1 refers to the parametric variable, and if you take the same parametric variable, we are talking about the same point. So this cannot be equal. So the result is T1 T2 is equal to minus 1. Now look at this. When you do the next problem, if you want, you can derive it in your examination. And if you feel that you won't get time, you can by heart this as a result. It's a standard result. It's used in solving many standard problems. Okay. So once more, let me explain very clearly what's happening here. Consider the standard parabola y square equal to 4ax. Point number 1, this is a parabola symmetric about the x-axis. And the focus of the parabola is a, 0. And the next thing, there are infinite number of focal chords, because focal chord means any chord passing through the focus. Now, if one end is given by a t1 square 2a t1, you know the parametric form, and if another extreme point is given by a t2 square 2a t2, let it be any focal chord, then you can use the result t1 t2 is equal to minus 1. Anyway, before you start the next problem, you have to explain this result. Now let me point out one mistake that many students make in the exam. Many students, when they hear the word focal chord, they go for the lattice rectum. That is wrong. That proof is not generalized. That's just a special case. You may get the answer, but that's a special case. So remember, when the word focal chord is mentioned, don't jump into the conclusion that they are talking about the lattice rectum. Focal chord means there are infinite number of possibilities. Focal chord, the shortest focal chord, or the focal chord perpendicular to the axis, etc., they may refer to the lattice rectum. Okay, so let's go for the next question. So please write the question. If rho 1 and rho 2 are the radii, this is plural, of curvature at the extremities of a focal chord. See, they have mentioned extremities of a focal chord. They never mentioned extremities of the shortest focal chord, or they never mentioned of the focal chord perpendicular to the axis. So you should not take the lattice rectum of the parabola y square equal to 4ax. Then show that rho 1 to the power minus 2 by 3 plus rho 2 to the power minus 2 by 3 is equal to 2a the whole power minus 2 by 3. Okay, now in your examination, I'll repeat, if you want, you can derive this, but that will waste time. It's better that you just mention this result. And what is the result? Okay, so you can start like this. Consider the parabola y square equal to 4ax. Let a t1 square and 2a t1, comma, a t2 square 2a t2 be the extremities of the focal chord. And you can draw the picture and draw a random focal chord. So this is our AT1 square 2AT1, AT2 square 2AT2, and then you can write the result T1 T2 is equal to minus 1, and you can call it equation number 1. Or you can do one thing, you can call T2 is equal to minus 1 by T1 as equation number 1. Okay, now let's start. I'm going to do it with parametric form. So given parabola is y square equal to 4ax, the parametric form is x equal to 8t square, y is equal to 2at. Shall we use the other formula? If you want, you can use the formula which we learned yesterday, but just to demonstrate the dash formula, dash double dash formula, I'll do it with that formula. So what is x dash? A into 2t. What is y dash? 2a into 1. I'll repeat once more. You can differentiate as you like. If you want, you can use the method I used in the previous two problems. Now, what about x double dash? That will be 2a into 1. What about y double dash? Y double dash will be 0. Now, the formula rho is equal to, you can check the formula, I kept it. So let's plug in everything into the formula. So x dash 2at plus x dash squared, by the way, plus y dash squared. So 2a the whole square, the whole power 3 by 2, the whole divided by x dash y double dash, that's 0, minus x double dash into y dash. So we get rho is equal to, here in the numerator I can see 4a square coming common, and then we have t square plus 1, the whole power 3 by 2, the whole divided by minus 4a square. So what will happen, this is 2 square, so we get 8 a cube t square plus 1, the whole power 3 by 2, the whole divided by 4a square. Let's ignore that negative. I told you why that negative comes. And the negative shows the concavity and convexity of the curve, the bending, upward downward bending. Now look at this. This is rho in general. It can be at any point, but we are asked to find rho 1 and rho 2, and we have to prove a relation connecting them. Anyway, in the relation I can see that we want rho 1 to the power minus 2 by 3, rho 2 to the power minus 2 by 3. So I think it will be much better if we write what is rho to the power minus 2 by 3. So that will be 2a to the power minus 2 by 3. That means it is 1 by 2a, the whole power 2 by 3. And here what happens is, we will get minus 1 by 1 plus t square. You can give it a try. It's very easy. Just applying laws of indices. Now remember, rho 1 means the value of rho at the extreme point. Read the question, you will be able to understand. So that will be 1 by 2a the whole power 2 by 3 into 1 by 1 plus t1 square, isn't it? That means the value of rho to the power minus 2 by 3 at a t2 square 2a t2. Okay, that will be 1 by 2a the whole power 2 by 3 into 1 by 1 plus t2 square. Okay, now comes the most important part. What did we prove? What did I explain just before the problem? We talked a lot before we started the problem, right? Yeah, T1, T2 is equal to minus 1. Actually, this is a result which you learned in class 12 conic section. Now what I am going to do is, since this is a focal chord, I can replace T2 with minus 1 by T1. Did you understand? So this becomes 1 by 2a the whole power 2 by 3 into 1 by 1 plus, what can I do with T2? It is 1 by T1 squared. That means rho 2 to the power minus 2 by 3 becomes 1 by 2a the whole power 2 by 3. Taking LCM, we will get T1 square by 1 plus T1 square. So basically we have found whatever they asked. Rho 1 to the power minus 2 by 3. Can you please read the question? We have to add them up and we have to prove that we are going to get this. Okay, time to add. So rho 1 to the power minus 2 by 3 plus rho 2 to the power minus 2 by 3, and that will give us 1 by 2a to the power 2 by 3 into 1 by 1 plus T1 square plus 1 by 2a to the power 2 by 3 T1 squared by 1 plus T1 square. And that means 1 by 2a to the power 2 by 3 will be common, and 1 by 1 plus T1 square will be common. The remaining part 1 plus T1 square. That's it. We got 2a to the power minus 2 by 3. That's it. Okay. So you can try one more question. Try it, because yesterday we did the radius of curvature of ellipse using Cartesian equation in the last video. And here I will give you the parametric form of the ellipse. What's the parametric form of the ellipse? X equal to a cos theta, y is equal to b sin theta. You can use any formula you like, but check whether you are getting the same answer as before. The answer is a square sin square theta plus b square cos square theta, the whole power 3 by 2, the whole divided by AB. Do it right now. This is a test whether you understood how to find radius of curvature in parametric form or not. So give it a try, and if you are getting the answer, please put a comment in the comment section, and I will be back very soon with radius of curvature in polar coordinate system and pedal equations. So till then, my friends, bye.